Hello and assalamu alaikum everyone. Hope you all are doing well. So today we will start our new topic. In this one topic we will cover our three topics. Number one is two forces of orbits, calculation of radius on orbit, calculation of energy on orbit. First of all, we should talk about the two factors of orbit. There are main two factors of orbit. One is called the centrifugal force and second is called centripetal force. Talking about centrifugal force, in centrifugal force what happens that we are having a proton over here with electron, okay, and this one there is the attraction between electron and proton, and this is called the radius, okay. After that, in electron we are having centrifugal force as we discussed in our previous lecture. So it's having mass and velocity both, okay. So what we have done, velocity we are having square from, because in square from initial to the final point, okay. So the formula of centrifugal force is Cf is equal to mv square upon r. M is the mass of electron, v square is the initial and the final velocity of the electron from centrifugal, and r radius is the proton and electron attraction between that, the distance covered, okay. So this is the formula of centrifugal force. Talking about centripetal force, in centripetal force what happens, okay, in centripetal force we are having the proton name as Ze and electron name as E. As I told you previously that in centripetal force we are attraction between two things, electron and proton, from one side to another. Towards attraction means inside attraction. So there are the two radius over there, from proton to electron and from electron to proton. So proton we denote it with Ze and electron we denote it with E just. So centripetal force is directly proportional to proton into electron upon their radius, okay. When we will remove this directly proportional sign, so we will put k constant over here. Let's move further. Okay, so we will put k constant over here. So centripetal is equal to k. Previously we are in previous one page we are having Ze multiply by E, so it will Ze square, and here we are having radius of both, from proton to electron and electron to proton, okay. After that, k constant is equal to 1 upon 4 pi epsilon naught, okay, as I have written over here that k is equal to, it's the constant value of k. So at the place of k we will put the constant value of k and multiply with Z square upon r square. When we will do this, so we are having the complete answer of centripetal force. The centripetal force is equal to Z square upon 4 pi epsilon naught r square, okay. Let's move further. So next we are having the sum of the key points over here. That first key point we are having that permittivity is a space where charges land, okay. Permittivity is a space where charges land and have change or attraction in charges is called permittivity. A small orbit have high or more permittivity, and large orbit means small have the high permittivity and large have the low permittivity. There is the opposition in both, okay. As I told you, what is permittivity? It's a charge space where charges land and have changes in attraction in charges. Let's move further to talk about the calculation of radius of an orbit. For the calculation of radius of an orbit, we will put the centrifugal force and centripetal force both equal to each other. So let's put the formulas of this both and find the calculation of radius, that how we'll find the radius of this both. Okay, so let's move further with this. As we are having centrifugal force over here and centripetal force. So centrifugal force is equal to mv square upon r, and centripetal force is equal to z square upon 4 pi epsilon naught r square. This r here, the centrifugal force r cut with the centripetal force r, and just we are having 1 r over there. So we are having equation that mv square is equal to ze 4 pi epsilon naught r. Okay, now move further, that r is dividing over here. You can check it out. R is being multiplied over here. When it will move in this one side, so it will be r is dividing over here. When it will goes to another side, so it will multiply with mv square. Okay, so mv square and r change both its position, that r moves over there because we have to find radius. So r comes over there, and mv square was multiplying over here, it goes on the place of r and it's dividing over here. Okay, so let's move further. Furtherly, we are having value of v. Here we are having v square, so we have to put the value of v square to find mode. So for that, what we have done, that for velocity we have taken the angular momentum formula. Okay, you can check out in this one box. So angular momentum formula is mvr is equal to nh. N is the number of orbits, h is the Planck's constant, and 2 pi is the value of angular momentum. Okay, so in this one v will just remain over here. Okay, nh will remain also same, 2 pi also. mv was multiplying over here, when it moves over there it will divide, so we are having mr, and v remain constant over there. Then we are taking square on both sides. So what happens, that on v we are having square, and the complete value of this we are having square. Okay, so we are having v square, n square, h square, 2 2s are 4, so 4 pi square, m square, and r square. This one square we will put in the value of r is equal to z square upon 4 pi epsilon naught mv square. So this value we will put over here. Let's move further. So when we have put in this one value at the v square, so v square is removed and its value came over here. Sorry, yeah, so its value came over here. Okay, now let's move further. After that, what happens, that r is equal to z square, then it was dividing over here, when it just inverse, so it up one side, so it's multiply. So what happens, that 4 pi square, m square, r square, it was dividing, when it moves here, so it multiply with z square, and n square and h square remain place same. Okay, so what we have done, that r is equal to z square, 4 we have cut in. Okay, 4 we have cut with 4, 1 there are the pi square, so we cut 1 pi, so we cut 1 pi with this 1 pi. We are having 2m, so we cut 1 m with another m, and just these things. So what's remain to us, so we are having just remaining r is equal to z square pi m r square upon epsilon naught n square and h square. Okay, now what happens over here, that we were having the value of r. Okay, then r is multiplying over here, because we have to find r radius. but r was multiplying over here, so we move on this one side, so it's divided over here. So this r cut with this one r, because this was 2r, so we are just having answer remaining 1 upon r. Okay, and this one equation remains same as this one is. Okay, after that we did the inverse of r, so the next value also inversed over here. Then r is equal to its this one value. Wait, let me show. This one value have inverse because of 1 upon r. Then r inverse, so this one value also inverse. So we are having this one formula over here, that is r is equal to epsilon naught n square multiply h square upon z square pi m. After that what we will do, let's move further. Okay, over here, so it here what we have done, that we have taken common in this one formula, so we have taken common over here n square and z. When we have taken n square and z common, we are having remaining this one value. Okay, and epsilon naught h square e square pi m, and this one value is equal to a naught. It's a constant value and it's equal to a naught, and a naught is also called the Niels Bohr's constant. Niels Bohr make this one constant called a naught. Wait, let me show. I hope that you are seeing this one over here. As I mentioned, a is equal to a naught, and this value is equal to this one value, and the value of this is 0.529 angstrom. Okay, it's the constant value of Bohr's constant. After that what we did, that in the place of this we put just a naught. Okay, we put a naught over here, or we can put the value of a naught over here, that is 0.529 angstrom. Then after that, here we have find the formula of radius, that how we can do the calculation of radius in an orbit. So r represent over here radius, n square represent number of orbits, and z represent proton. Okay, now we will do one problem in which we will discuss this one formula. Okay, so here's the problem that says that calculation the fourth orbit of radius of hydrogen. Here they have given the fourth orbit and also given the name of atom, that is hydrogen. So n square is equal to 4. Okay, radius we have to find, and we know that in hydrogen we are having proton 1, so we have using this one as a formula. This is a formula. Okay, and in which we have put the value of n square. N square value is 4, so here is 4 square, z is equal to 1, and I told you that a naught value is 0.529 angstrom. Okay, after that 4 4 is 16, and we receive this one value when we multiplied it. So radius is equal to radius of hydrogen of fourth orbit is equal to 8.464 angstrom. What the value is? 8.464 angstrom. Hope you understand the calculation of radius on orbit.